Good morning, everybody. This is Cory from aspenweather.net. Let's start by reminiscing just a little. If you watch the video before Saturday's storms, what did my old ass harp in on? Instability was the key to that event. We also mentioned CAPE, which stands for Convective Available Potential Energy. CAPE is a parameter we use in the summertime for thunderstorm development. So when you have CAPE on a winter's day, which is what Saturday was, it's winter, that's rare. Moral of the story, I went 4 to 8 inches on Saturday, and the bursts of snow help us to get, we got the 4 to 8 inches. That's great. Aspen Mountain had a little bit more at the snow stake, nine, maybe 9.5. It's hard to tell on the snow stakes when it's windy at times. Okay, so let's go to yesterday. We had two batches of weak mid-level energy on Sunday. Those batches of energy didn't cause much vertical motion, but here's the deal. We had an upslope northwest wind at mountaintop, and we have complex terrain. So what I told you all was going to happen was we would have stratocumulus clouds in the valleys. Every now and then some flakes would fall from the bases of the stratocumulus clouds, and that's what happened. Up at the ski areas, there was 1 to 2 inches and change up there. The 2 inches came from like 11,400 feet up to 12,000 feet. But in the lower parts of the ski areas, about an inch happened. So everything's turning out just fine. And let's talk about today, Monday. So the first graphic is as follows. You see the energy over southern Oregon and northern California. Those are fairly bright mid-level colors. So you know what I'm going to do next. I'm going to show you the water vapor loop so we can make sure this energy is real. So let's go to the water vapor loop. Oh my goodness, I could cuss on that. Once again, it is perfect. Look at this graphic. See, you see this little batch of red mid-level energy? Look at the water vapor loop. It's got it. It's perfection. Back to this graphic. See the bright reds coming into Northern California and then spreading east? Look at the water vapor loop. There's the dark colors heading into Northern California. So the water vapor loop matches what this is, what the models say. So that means the models are analyzed correctly and they're in good shape, and this water vapor loop is identical, and that proves it. All right, let's go through just a couple graphics. This is at 2 p.m. this afternoon. Here's the thing to notice and why this storm is slightly different. This is the energy that I just showed you on the water vapor loop, 10, 12 hours ago. But look where it's going. It's diving to the southeast. None of these bright mid-level energy colors are in Colorado. Remember, the brighter the color, the stronger the energy. Okay, so this graphic is showing you that the best energy is well southwest of us. Over our area, that light blue color, you can see it down here, is fairly weak mid-level energy. Next graphic, 8 p.m. See what's happening still? The really good mid-level energy is well west and well south of us. This is not bad, though. See this energy here in Utah and Colorado? Aspen's right about here. There is some low end moderate mid level energy and some light blue. So it's weak to occasionally moderate energy that spreads in here from Utah late day and into the evening. Let's go ahead and go till 2 a.m. Once again, the big blob of good energy is well to our west and well to our southwest. Here, though, we still have some energy that comes out of Utah and drifts across Colorado late day and during the night. All right, let's look at precipitable water really quick. Remember the atmospheric river event? I showed you what precipitable water is. The higher the number, the better. This is at 5 p.m. today. We have 129% of normal ambient water through the entire vertical column. So that's not bad. 129 is not bad. It shows that we at least have some ambient water to get potentially lifted by this mid-level energy batch there and this little energy batch there. So it's good that we have ambient water that's above normal. I'm just about done. I won't babble too long this morning. Let's go to the snowfall totals from the GFS. All right. The 2.3 is basically, think of that as near Aspen Mountain. Okay. To get to Highlands, you have to go southwest. So Highlands, see the light blue? Highlands is in that next color, which says around 2.5. Snowmass, if you go west of Aspen, it's around 2. It's that first blue color. So the GFS is forecasting 2 to 2.5 inches. This is a 24-hour forecast, 5 a.m. Monday to 5 a.m. Tuesday. Let's look at the European real quick, and then I'll be done. The European has 0.7-ish, or basically an inch near Aspen Mountain. If you go southwest towards Highlands, you got to remember to do that. We're on that first color of light blue, which is 2 inches. If you go west towards Snowmass, it's very close to that light blue, but it's more like the dark brown, which is around 2 inches. So GFS has 2 to 2.5. The European has 1 to 2 inches. So the models aren't in that bad of agreement. And it makes sense that we don't have big snow numbers because I showed you this mid level energy. It's not that strong. It's nothing compared to these reds. So when you have not as intense colors, you don't have as much vertical motion. So that's really the point you need to understand today. In my forecast, I'm going 1 to 2 inches of snow. If I have to update it later and we get 2.5 or 3 inches, that's okay. In general, the 1 to 2 is probably going to work. And also, this European map is valid 5 a.m. this morning to 5 a.m. Tuesday. So, I mean, that's basically it. It's good. Saturday we had 4 to 8 inches. Yesterday we had 1 to 2, and a couple of the high level sensors got 2 inches and change. If we can get another 2 today, 1 to 2, it sure is better than nothing. So January is proving to be a lot better month than December so far. All right, I'm done. You all have a great morning. Catch you later. Bye.